So today I'm going to discuss the ISI MStat 2017 PSB problem 2. Let's move ahead. So what are the prerequisites for this problem? It's high school calculus and a Rolle will perfectly do. Now what's the problem? Let's come to the problem straight away. So we are given a function from R to R which is infinitely differentiable, and it's given that for some natural number n, f1 and f0 equal to 0, those 1 or 0 are the roots, and also the nth derivatives, the first derivative, second derivative till the nth derivative at 0 are 0. Great. So what we have to prove? We have to prove that there exists an x between 0 and 1 such that the n plus 1th derivative at x is 0. Great. So as you know that from the prerequisites we need Rolle's theorem. So let's come back to the geometry of Rolle's theorem. So we are given this picture, and you see, let's see its Rolle's theorem obviously. And what does Rolle's theorem say? That if a real valued function is continuous on this closed interval AB and differentiable on this open interval a comma b, then and if a equal to fb, then there exists at least one c in the open interval a comma b such that f dash c equal to 0. Great. So that's what you see from the diagram, right? So if a is 0, if b is 0, and at c if dash c is equal to 0. And that's very intuitive from geometry, and that's what Rolle's theorem says. Great. So what's the main idea behind this problem? Obviously it's Rolle's theorem. So let's see how it is applied to this problem. So f0 equal to f1 equal to 0. It's given. And by Rolle's theorem there exists x1 such that x1 between 0 and 1 open interval such that f dash x1 is 0, right? And we are given the condition that f dash at 0 is 0. So we can use these two properties, the thing we got and the present condition, to get there exists an x2 between 0 and x1 such that f double dash of x2 is 0. And we also given the condition f double dash as 0 equal to 0. So we can use this two together to get that there exists x2 between 0 and x2 such that f triple dash of x3 is 0. Left hand, right hand side, if you see that, what's next? It is continuing, and if you continue just by this method, you get xn between 0 and xn minus 1 such that f n dash of xn equal to 0. So this jump of steps you must get it. So we are doing that for x first derivative, second derivative. It's repeated Rolle's theorem application, okay? And also we are given that the f n dash at 0 equal to 0, the final condition, and using this condition and the derived condition we get that there exists an x between 0 and xn which is a subset of 0 and 1 because we are required to prove for between 0 and 1 such that f nth plus 1 at x, nth plus 1 derivative of f at x is equal to 0. X is the number, okay? So QUD. So it's proved, but you don't know, we don't stop so easily. So we have arrived with some food for thought, some continuation of this problem. What's the first one? So what if I ask that does there exist such a function with a given condition? So it's your job to solve this problem, to find a function with the given conditions and verify for that function. Great. What's next? And let us know in the comment section, okay? What's next? What if I loosen the condition that for some n it's becoming, it's like till that n its n derivative is 0. What if we remove that condition and tell for all n it happens so? And if I tell that f1 equal to 0, f0 equal to 0, and also all the derivatives at 0 is 0. Can you find such a function which is infinite differential? Does Taylor theorem help by his Taylor's theorem? You see, like that's a hint, obviously. So, but the hint is counterintuitive, okay? So solve this problem and let us know. For more, visit our website and our YouTube channel, cheenta.com, and don't forget to like, subscribe, and share.